Good morning. 10-6 outliers. What the heck are outliers? Well, remember we're still doing data, so outliers are data points that lie outside the range, like they're way out there, okay? If you had a set of data and most of your data was like right in here, boop, that one would be an outlier, way outside of everybody. Okay, so today we should be able to understand how outliers may affect the measure of center. Measures of center are going to be mean and median. And determine which measure of center is most appropriate to use when describing a data set that does or does not contain an outlier. Okay, when we use the mean, sometimes we'll use the MAD. When we use a median, we're going to use our IQR. An outlier is a data value that is very far away from the other data values. Boom. And there's a specific way to find it, and you got to follow the way. There's a little formula and everything, okay? So if this is our data set, we put them in order because we're going to have to use our IQR, okay? So we're going to have to find the median. The median in this case is 387.5 because it exists between these. Quarter 1 was at 300 and quarter 3 was at 475. You can't remember how to do that. It's a little earlier on in this unit. And then to find your IQR, you take Q3 minus Q1. We can write that down for you. IQR equals Q3 minus Q1. Okay, so in this case, 475 minus 300 was 175. So the IQR is 175. So how do we find outliers? Basically, how do we see if 225 is too small to really be included in the data, or if 780 is too big to really be included in the data? Well, here's how. You're going to take Q1 minus 1.5 times the IQR. If your IQR is 175, now we can just substitute the values of the variables. We know the IQR is 175, and we know Q1 is 300. So we just substitute them in and then do our math. And we end up with 37.5. So is our smallest value smaller than 37.5? No. That means 225, totally included, not an outlier. And then we'll look at our upper limit. So Q3 plus, because now we're getting bigger instead of getting smaller here, Q3 plus 1.5 times the IQR. The IQR is still 175. Q3 was 475. We said that earlier. Substitute the values of your variables, do your work, and you get 737. Is 780 bigger than 737? It sure is. This is your outlier. I'll tell you what that means here in a moment. First, we got to just know how to find the outlier. So when you're plotting your data, remember your IQR is in these two middle boxes, your small whisker and then your large whisker. This large whisker would be this long. And that would tell someone, oh, all the data in this upper quarter is absolutely spread out all the way up to 780. And that wouldn't really be true because there's only one value up here at 780. All the rest of the data points are down here by 625 and smaller. This is a more accurate representation of the data and then telling you then there's one way out here. Okay, so that's kind of why we find it. And this can move some other measures of center. So let's practice finding outliers. The ages and years of candidates in election are 55, blah, 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 blah. Find the quartiles and interquartile range. We can do that. List them from least to greatest. So my smallest one, 23. And then 48, 49, 55, 57, 63, 72. Okay? Now remember to find the median. 1, 1, 1, 1, 1, 1. Okay, here's my Q2. Or the median, 55. Quarter 1, now you don't include the median when you're figuring out your quarter 1. Boop, boop. There's quarter 1. And 63. Okay, so the IQR, remember, is Q3 minus Q1. 63 minus 48 is 15. So our IQR is 15. Okay, now to find the upper limit, or to see if this number is an outlier, we got to just follow the formula. Q3 plus 1.5 times the IQR. Well, the IQR is 15. And 1.5 times 15, I think, is 22.5. 22.5. Which is also going to be 22.5 over here because it's 1.5 times the IQR. Quarter 3, we said, was 63. And 22.5 plus 63 is 85.5. So is this value bigger than 85.5? No. That means it's fine. It's not an outlier. Let's go over here. Q1 is 48. 48 minus 22.5 is 25.5. So is this number smaller than 25.5? Yeah, that means this is an outlier. 23 is an outlier. Okay, so that's how you find an outlier. Then what do you do with it once you find it? Well, let's go over here. If a data set contains an outlier, the outlier may affect the measures of center and/or variation. Suppose you track the daily high temperatures for 1 week and the results are recorded in the table. Sunday, Monday, Tuesday, Wednesday, Thursday. Wait, where's Saturday? Well, these temperatures look pretty similar. Suppose that the high temperature on Saturday is 42. This temperature is much lower than the other temperatures in the data set. It is also an outlier because 42 is less than the lower limit for outliers. And then they have done the work for you. Quarter 1 minus 1.5 times the IQR. They found all of that in this example, but if you had to decide on your own, you'd have to do the work. And they said 59 was the lowest, and 42 is obviously lower than 59. So this is an outlier. So now let's decide, how does that affect anything, okay? This is really when we're getting to the point, okay? To see how an outlier affects the measures of center and variation, calculate the measures both with and without the outlier. So calculate the measures with the outlier first. So they found the mean, included the outlier, remember 42, totally an outlier, and they said the mean was 67.7. Then they calculated the median, they got the IQR, and we're going to figure out the MAD because they didn't do that for us, which is no problem. So our median is 72, so we're going to take 72 minus 42 and we'll get 30. 72 to 68 is 4, to 71 is 1, to 72 is 0, to 74 would be 2, and to 75 would be 3. 34, 35, 36, 37, 38, 39, 40, and 40 divided by 1, 2, 3, 4, 5, 6, 7. 40 divided 7 is 5.7, and want to round to the nearest tenth. So 5.7 is the MAD. The median is 72, and the IQR is 6. That's all with the outlier. Then you have to do all of that again, but without the outlier, and then we can compare numbers. So without the outlier, when they found the mean, notice the outlier's gone. And the mean came up. It was 67.7, and now it's at 72. But notice the medians are the same. Our median was 72, and this median is 72. The IQR here now is 3. See, it says 3. And then we'll find the MAD real quick. So 72 to 68 is 4. to 71 is 1, to 72 is same, to 74 is 2, and then 3, 4, 5, 6, 7, 8, 9, 10. So we'll have 10 divided by 6 now because we're only having 6 data points because we dropped out the 7th one. And now we have a 1.67. And let's just round to 1.7. So now look at their MADs. We have a 5.7 and a 1.7. Okay, who cares? Well, this means that the data points are closer to the mean. That's all that stands for. The data points are closer to the mean than up here. There's more variation. They are less consistent. Here we have more consistency. Okay? So if we were going to choose a measure of center that would work with both of them, which measure of center stayed the same? Is it the mean or the median? Yeah, it's the median. The median stayed 72. So that would be a better measure of center no matter if with or without the outlier. If we're going to use the mean, then we got to be sure to tell people that the outlier is or is not there. Okay? I know that was a long lesson today, but this was actually, it's just a lot of information. It's a lot of thinking. You're in a thinking stage of math right now, so turn it up. Remember, you've got all this here if you need to go back, and obviously you can rewind. All right, good luck.